Hi everyone, let me introduce myself to those who do not know me. I am Ashnat Kothari, a qualified fellow actuary. I am the founder and director of Finatics. Finatics is involved in providing classes for actuarial exams, placement assistance, along with plenty of other services which a student needs at different phases in their journey to become a qualified fellow actuary. I have been professionally teaching actuarial science for the past 8 years, having mentored students not only from all parts of India but from across the globe. Now, coming back to the much awaited announcement, the reason why you are here, we are extending an opportunity for students who have not studied with us to join our classes, get mentored by us for the preparation of actuarial exams by paying zero tuition fees at outset. Yes, you heard it right. Zero tuition fees at outset. This is valid for classes of CM1, CM2, CS1 and CS2, whether you are appearing from IFOA or IAI. Ones who would be joining us for the first time can see how we go about with our classes, the educational content we provide, the doubt clearing facility we provide, the sort of guidance, unbiased guidance we provide. And after spending some time, if you find value in the educational content and guidance we provide, you can pay the full fees. Now, you might be wondering as to why we are coming up with this opportunity, even though Fanatics is at its peak with respect to the performance of its students in actual exams as well as their professional career. The reason is simple. You will not see us extensively marketing over social media, be it through Insta Reels, YouTube Shorts, or other various ways. You will not see us coming up with new batches on a regular basis or flexing the number of students we have and outrightly ignoring the proportion of students who clear the exams or who even continue with their journey. Being in the education industry, we make a conscious effort to channelize majority, if not all, of our energy and time towards ensuring that students are having a proper learning journey, not just spoon feeding them everything so that they might get certain favorable results in the short term, but by ensuring to make them independent, capable of working independently, even in our absence, and therefore succeeding both in their personal and professional journey in the long run. Do note that we continue to have one single batch for each paper each term to ensure that all our students are getting sufficient time from the faculty. Do keep in mind that at Fanatics, it is the main faculty, be it Gunjan or me, who are involved in taking the classes, doubt clearing, or any sort of guidance or any sort of assistance which the students require in the preparation of their actual exams. As such, we will restrict the number of intakes to 50 for each of the papers. In case you are already studying from us and you are happy with the way we go about with our classes, continue to study from us. For ones who have not studied from us but who are looking forward, this is the best chance for you all to join us, experience how we go about with our classes. If you are a sincere and hardworking student who wants to excel in your actual career, do join Fanatics today for a meaningful, impactful, and wonderful learning experience.
Hi everyone. So in this video, we shall be taking a look at indicative solutions of CS2A from IAI May 2024 session. Now, first of all, let me brief you regarding the objective of this video because it is slightly different from the IFOA solution discussions video which we release. So IFOA releases its examiner report post its results only. So students have to wait for around 10 weeks or so to know, how they could potentially fare in the exam. And in this time period, sometimes they don't start preparing for the next term and they end up losing a lot of time. For II, that is not the case because in the last term, as well as what we expect in this term, is for them to release their indicative solutions right post completion of exams. So let's say by next weekend itself, we should expect the indicative solutions to be released. Now, you might ask then what is the purpose of this video? So it's twofold for me. One is there, it encourages me to, solve the questions, continue to stay in touch with the subject, and also in case there is any sort of error in the indicative solutions released by IA, I can, point them that, this or this might be mistaken, so you can take a look at it and rectify it. Because in the last term there were certain subjects where the indicative solutions had errors, and then later on II had considered it once students and as well as we raised it with them, and they released the correct set of solutions. Second thing is key for students who might be giving CS2 in future. They can take a look at the videos because we'll be discussing the tricky questions or certain difficult questions, so these can be used for future reference as well. We do it for IFA, and going forward my intention is to continue to do it regularly for IA as well. Now, for the solution key of MCQs, you would be finding this in the comment section only. The comment shall be pinned. Some numericals or some MCQs we might discuss it in the video as well, which might be tricky or slightly difficult. And don't forget to subscribe to our YouTube channel so that you are updated regarding all the latest educational content we share. And in case you find this video helpful, definitely do like it and share it among your viewers pursuing actuarial science as well. Now, getting started with the discussion for the paper, how I thought this paper was, it was fair. I will not say this paper to be very difficult or very easy. It was a fair paper. Well prepared students, who had practiced adequately would have found a lot of questions pretty similar to what has been asked in the past years, be it in IFA past year papers or II. And again, given the structure with 40% of MCQs being there, it did eliminated a lot of mathematical typing as well. If not eliminated, it rather reduced. Now, obviously, one of the issues with these MCQs when they have 3, 4 marks is there is no step marking. So now the point is whatever way the exams might be kept, there could be obviously some or the other disadvantages accompanying that particular format. So there's no point of coming up with a very best format exam because there will be none, but it's more about, which exam format might be the least worst. So given that most of the students didn't want to study mathematical typing, something I was also, personally think that the amount of time we need to put into, learn it and the value which we get out of it, it just doesn't add up. So actually, I don't see mathematical typing to be giving us such value, in comparison to the time we need to spend. Again, whatever we might know, it's going to help us only, or it's good to know more things as possible, but there's the opportunity cost of the time you're devoting to, master a particular skill. So let's take a look at the questions. Question number one, fairly straightforward. You have three data, two losses exceeding 25. So truncated data for two. And for three of exact data, you can find the likelihood, take the derivative and solve for it. Part two is from machine learning, straightforward. Part three is also pretty much straightforward, where you have these transition matrix and you need to ensure that all of these are lying between 0 to 1. Part 4, so if you see the formula, mx is nothing but qx divided by integral tpx dt 0 to 1. Now this integral value lies between 0 to 1, therefore your mx shall always be greater than equal to qx. Question 5, very straightforward. I will say it's kind of free 1 mark which you're getting. Question 6, again, it's from machine learning. Question 7 over here. So subtraction of two Poisson processes, it does not follow Poisson process as such. You can just think in this way. What if n1t is say 1 and n2t is 2? 1 minus 2 makes it minus 1. So Poisson process cannot take a negative value. So definitely this is not a Poisson process. Question 8, again, this is straightforward result which we use that E naught x is approximately equal to Ex plus half. 9 also I will say pretty straightforward. 10, standard application of Gompert's law. 11 over here, a probability that a healthy life will never become sick. So it's 0.04 plus 0.9 into 0.04 plus 0.9 square into 0.04, so on. So basically the person needs to go directly to death state from healthy state. So if we make this GP, it will be 0.04 divided by 1 minus 0.9, which will come out to be as 0.4. Question number 12, again, a rather straightforward one. I would say there was obviously some calculation over here when you need to find the CRLB and compute. Then question number 13, this also I would say is fairly easy, honestly. 14, again, very straightforward. What is time series? In the sense it has a continuous or a discrete time set or a state space. Question number 15. So we need to find the quartet expectation of life. So basically the formula is 1px plus 2px plus 3px, so on. So 1px is nothing but e to the power minus mu. 2px is nothing but e to the power 2 mu. minus 2 mu and so on. So you have a GP with the first term as e to the power minus mu and common ratio as e to the power minus mu. So if you compute it, you'll be getting something like 99.50008, which is roughly 99.5 years. And you can also use the fact that your expectation Tx will be nothing but 1 by mu, which is integral Tpx dt, and Tpx is e to the power minus mu t. So your expectation of Tx, complete future lifetime, is 100. So your curve will be approximately equal to 100 minus zero point 0.5, which is 99.5. Now again, over here, this approximate is working well. In some case, it will not work well. So you might get the answer over here using the approximation as well, but that is technically not the correct way. The accurate way is summing up 1px, 2px, 3px, so on. Question number 16 also, over here they need to find F1 score and accuracy. So over here, once you get F1 score, you will see it's 92.7. So you don't even need to complete the accuracy part over here. Question number 17. So this is, you need to find the probability that a person age 65 exact will die between 85 and 88. It's again, I will say, fairly straightforward. Question number 18. Yes, this question, a very similar question like this is there in the acted material. Maybe the last question of the material. It has been come, in the past paper of IFOA as well. So over here, if we quickly, look through it, there are three times 135 where decrement of interest is taking place. So at time 1, it's becoming 0.9. So your ST is 0.9. So your 1 minus lambda will also be 0.9. So your lambda will be 0.1, which is nothing but 1 by 10. So your DJ is 1, your NJ is 10. Then in this time 3, your ST is 0.675. So if you compute, lambda J, you can do it by 0.675 by zero point 0.9. So you'll be getting it as, if I remember correctly, it was maybe 0.75, which is maybe 6 by 8, 3 by 4. So your lambda j should be 1 by 4. Now for 1 by 4, there are two choices. It could be 1 by 4 and 2 by 8. Because of the next value, it cannot be 1 by 4, it must be 2 by 8. So we take it 2 and 8. DJ is 2 and NJ is 8 at time 3. Similarly, at time 5, you will see this will correspond to the case where DJ is equal to 1 and I guess NJ is equal to 5. So total number of deaths occurring is 4. So the option, it would be B. So this was again through trial and error and through observation over here. I personally, prefer these kind of numericals. It kind of tests even your observation skills comes into play, which I feel for an actuary is very important. It's not just about looking at numbers; it's also about making business sense out of it. So for that, one should have a very keen eye for numbers and to comprehend. Sense check what numbers are there, how you can manipulate multiple things to get maybe some other quantity, just to have a feel of the numbers if they are sensible or not. Next, question number 19. Again, I guess this similar type of question is there or has been tested in IFA also. I don't remember specifically of II. It might be there in II also, but it's there part of revision note. So it's definitely been tested in II itself. So if I'll take a, in IFA, I mean, if I'll take a look at the solution, just again, keep in mind that I didn't get much time to cross-check my answers. So in case you come across any errors, do let me know through the comment section. I spent maybe an hour or 75 minutes max in solving this. So there could be certain numerical errors. So do let me know. I'll take a look into it, and in case I find merit in it, we'll definitely put in through the rectifications through the comments section itself. So this is the solution. Honestly, we just need this value, this value, and this value. I was gonna write all 9 values and then realized there's no point of wasting time. I had written the third this value. This again is not needed for computational purpose. So A is 0.7, B is 0.5, D is 0.3, and C also, if we'll solve, there are two values. It can't be 0.9 because C plus D must be less than 1. So C must be 0.5 only. Next, question number 20. Again, a very similar question like this has been tested in IFOA. So most of I assume that even if you're preparing for II, you would be solving faster IFOA questions where you will be getting, and even in II questions, you get something, pretty similar on these lines as well. So first thing is the formula is, I should begin with either H naught and H1 definition. So over here they have written H naught good fit, H1 bad fit. I don't feel this is the best way. It's more like whether the graduated rates are true rates or not, and H1 is graduated rates are not true rates. So it should be in that way. Next is this should be A minus E whole square divided by E and not A. If you would remember, it's O minus E whole square divided by E. Then degree of freedom also they have just done 75 minus 75, that is wrong. First of all, to begin with, you have six values. Then because of graduation with reference to standard table, where you're subtracting a constant. So now it depends if the constant is also, kind of estimated, there will be one deduction for it. And then there will be certain constraints coming in from the choice of standard table also. So you might deduct another one or two for that. So in total, you might deduct two or three. So your degree of freedom could be, let's say, three or four. Next, this goodness of fit test, the one-tailed test and not a two-tailed test. So this is also incorrect. Um, Next, when we write we accept the null hypothesis, this is a classic mistake. Ones who have studied CS1 from us, they will know that I always say this is a wrong statement to make. We always try to put it as we have sufficient evidence to reject H naught or we have insufficient evidence to reject H naught. It's not technically right to say we accept the null hypothesis. The right way is we have insufficient evidence to reject the null hypothesis. And then you could also state in your conclusion at the end. So I will now kind of summarize this. Also, if it's a 5% level of significance test, I mean, the critical value should be quoted at 5% and not at 2.5%, which they had done because they had taken it to be two-tailed test. Next question from time series, part one is, pretty direct work, standard derivation over here, where you'll see rho k is nothing but alpha to the power k. Part two, again, once we have studied CS2 from us, the same numerical we have done in the class as well. And this has been tested in past year paper of IFO as well. So what we want is that rho k should exponentially decay towards zero as, the value of, I mean, after differencing d times, your as the value of k increases, when I say k, it's for row k. That is, as we move down the rows, it should exponentially decay. So we see that happening in k equal to 2. So we need to difference it twice. And now they have asked for the average value. I'm not very sure regarding, what they are looking when they say average value of parameter. I just equated 0.83 to alpha because rho 1 will be nothing but alpha. I'm getting it as 0.83. So I'm not sure about this. I'll have to refer to maybe solution or give a bit more thought to, see what exactly the question is trying to ask. Part two, again, they have given you the value. You need to perform these three tests. So these are pretty straightforward, mostly computational. So I've not done it. It's there directly there in the material, all the formulas. You need to just, apply it over here. 22, again, this was a good question. A pretty good question that way, I guess most of you might have struggled in part 6 and 7. So let me just go through it. So these are for the first five parts. Now, one thing which I would like to highlight is I'm not sure if I have done part 6 correctly because it's given just 2 marks and the amount of steps I had to do was even more than part 7. So I'm not sure if I have comprehended the question correctly or not. It could be I've done it wrong. I have not spent much time thinking about it yet. But yeah, in case I do find any error, I'll let you all know through the comment section. And again, see the solutions by AI would be coming. So anywhere that is the ultimate source of truth once it's completely error free. So you can take a look from there as well. In the meantime, this is what I have done basis my interpretation of the question. MI is the expected time to reach room 1 given current room is I. So these are the equations. I have simultaneously solved them. Ultimately, I need to find M1. And after, performing a lot of computation, so on, I'm getting M1 as nothing but 12. Now, part 7, it's again, it's basically starting from room 1. We need to find the expected number of steps to reach room 5. So now I define M1 to be expected time to reach room 5 given current state is I. Pardon the poor quality of this image. I'm realizing this right now. So again, you make similar expressions and M5 again is nothing but 0 itself. Uh, so mm, let me just see one thing. If I'm defining it expected reach one given current room is I, if I'm already in room 1, I need to return back to room 1. The question is to return back to room 1. So this is of expected time to reach room 1 again, given current room is 1. So if I move forward to the next part over here, I'm getting M1 as 7 over here. Now next question number 23. This was a fairly straightforward question, I will say. Define the random variables over here. Let me just zoom in the image for you all to take a look at same. N follows Poisson 1.9, X follows Pareto 4, 900, Y follows uniform 50, 100, X and Y are independent. So let Z be the total loss amount on an individual claim, including the expenses. So this is how I get it's coming out to be 375 into 1.9, which is roughly 712.5, or variance S is lambda expectation Z square. EX square plus EY square plus Y is expectation X into expectation Y. You can substitute all these values, directly take it from actuarial tables, the formula, put it in, and you'll see that it's similar to the answer provided. Next, part 3 is the revised mean of S. So 1.9 into 300 into 1.2, the inflation is acting on this, plus 75, it's coming in 26.5. And now if I take a look at the question, part 4, insurer planning to impose deductible D that would result in insurers' expected aggregate payments being the same in 23 and 24, and they have given hint as well. So again, I have not really checked my calculations on this. There might be an error. I have not spent much time so particularly raising this. So this is the thought process. S is, let's say, Z1, Z2, Zn. Z is nothing but W plus Y. So let's say 2024, where this is the definition of W, and then this is the hint, not the definition of W. Now, if X follows Pareto alpha comma lambda, then 1.2x will be following Pareto alpha comma 1.2 lambda. You could derive it as well to check. Now, let T equal to 1.2x. So T follows this Pareto distribution. So now W is nothing but T minus D, given that T is greater than D. So now using the hint, again this FW1, what I see is that W is following nothing but Pareto A comma B plus D. Now, next thing is that the expected value. Now, if we'll compare expectation S in both the years, expectation N is same, expectation Y is also same. So what I need to do is that the mean amount paid in 2023 by insurer should be equal to the mean amount paid by insurer in 2024. So this is the mean amount. This is the conditional mean. Expectation W, this is basically probability of the amount being greater than deductible. So I need to find the unconditional mean, and I need to equate this to 300. And on solving this, I'm getting D as, 103.08. So again, I'm not very sure. I haven't given it a thought whether I'm being consistent or not. So just highlighting it in case you'll find any errors in calculations or concepts, do let me know. I'll take a look into it as mentioned earlier. So this was regarding how the CS2 paper was. Hope that you all found this video particularly useful. Definitely do like this video and share it with your peers who might have sat for exam in this session. Thank you, everyone.